All right, welcome exclusive tutoring math superstars. What I want to do today is go through a little bit of the calculus that you guys may be encountering right now. So without further ado, let's jump right into it. We're going to jump right into what I have here is my calculus study guide. And we've got to talk a little bit about what you should expect when it comes down to these specific components. Okay, so what we got to talk about, you guys probably already know this, but in here, you've got your fundamental theorem of calculus. That's your limit of h approaching 0, f of x plus h minus f of x all over h. What this is it's a instant rate of change. Okay, it's an instant rate of change. It's a slope where the bottom is as close to 0 as we can get it. All right, and your teacher's probably already gone over the continuity idea, where the limit as it approaches from the left, the limit as it approaches from the right, and the value itself all need to be equal for something to be continuous, okay? And what continuity means is ultimately it's a sign that the data is measurable in terms of the change that's happening, okay? With that as well, we got to talk about our theorems. There's basically 2 of them, but we have 3 different words to describe what's going on. The mean value theorem is that the average rate exists. Okay, so if I give you an example of, like, let's say you're going 60 miles per hour and that was your final average speed of your trip. Well, average means that you very likely had to have gone values above and values below this, and there was an average that was calculated that gave you the 60, which also means that averages generally exist somewhere in between what we're dealing with. Okay, for example, average height. Would you possibly have, let's say 5'6" is the average height. Is it possible, right, for, if you think about it, for nobody to exist at 5'6" and them to all to be shorter or all to be taller? That would not be possible, because for it to be an average, it has to generally lie somewhere in between the values that exist, okay? So that's where the average rate exists. Let's continue. Rolle's theorem is the same idea, but it's a slope or a change of 0, okay? Right, I think of our O, the O is a big 0, right? Mean value theorem, intermediate value theorem don't really have a 0 or an O in there, in the mean value and intermediate value part, right? So the O, the way I explain rolls is that you may have a point and another point which are equal, okay? So f of x or f of a and f of b are equal. Therefore, when you subtract them, right, because you have this basic slope equation, if they're equal, it's a big fat 0 at the top. And so that's your overall slope. Now remember too, if with mean value theorem, which is the same as Rolle's, it says if you have an overall slope of 0, there has to be a slope of 0 somewhere in between. Okay, so let's talk about the easiest case. If it was just flat ground, right, you look around in any building that you're in and you look at the ground, it's flat from where you're standing till somewhere else. Does the slope change? No. And is the slope 0? Yes. Okay, so that's a part of Rolle's theorem stating that anywhere between where you're standing to the other point, which is also flat, there has to be flat ground in between. Okay, now let's talk about this in terms of like elevation or money, for example. If this was a if this was a peak of some sort of, there we go. Okay, the peak of a mountain, and then you look across and you see the peak of another mountain, and you're at the same level. That makes sense? Now, the idea is that if you wanted to get back up there, you're going to have to hit a point that is likely a slope of 0. There's a bit of flat ground before it goes back up. And that ultimately shows how the slope of 0 exists somewhere in between. All right. We'll talk a little bit about what the slope of 0 means, because it's a special case, but in a lot of situations, what it generally means is that there's a possibility of your numbers, your data turning back around. So if this was money, right? If this was a money situation, what that would mean is that, if you had $1,000 here and $1,000 there, but stuff had happened in between where the money may have fluctuated, then there's points in which the money may have turned around in order for you to end up with the same amount. So you could have spent money and then it came back. You could have made money and you could have spent that. Either way, the beginning to the end turned out to be a slope of 0. And therefore, it ends up meaning that there was a turnaround point somewhere in the graph. Now, intermediate value theorem, I don't want you to think too much about it. Intermediate value just means in between, okay? So the values in between must exist. So if you have f of a, right, which is a and f of a, and then you have f of b, which is at b, you can imagine that if you understand that price or elevation went from here to here, that's all you're given. You're given 2 points. You can understand that the values that exist in the middle of it must exist, okay? But the values outside of it are not guaranteed. That makes sense? Values are all around it cannot be guaranteed because you don't have data to support that. What would be a real life example for this? Well, this could be, day 1 and then day 10. Well, you understand that these 10 days exist. Does that make sense? If you have point, let's say again, $1,000 and then $2,000, well, you can assume that the values in between exist, but you can't assume you had 2001. You can't assume $999 or lower, right? And you can't assume anything about day 0, and you can't assume anything about day 11 and on. So what it does is the intermediate value theorem states that if you're given the domain of 2 points and then the range of 2 points, all the numbers in between should exist, but nothing outside of it is guaranteed. Okay. We'll go into L'Hopital's rule and squeeze theorem later. You probably have already done your power rule, product rule, learn to apply the fundamental theorem of calculus to your graphs and to your polynomials, what to do if you have quotients and chains and things like that. And I know some schools have gone so quickly that they're already done with their trigonometric derivatives and the inverse formulas too. So what that leads you into next are all of these things that I consider the applications. What they turn out to be are they have parts from the beginning that now get applied, and obviously we change around the level of difficulty depending on how difficult that polynomial or how difficult that function really looks. So here's how I look at it this way. You have a couple of different ways that they've set it up. Your tangent lines help you understand what linearization is. Implicit differentiation, just like right here, helps you understand and leads into your calculations for related rates. Then your optimization is your max, min, concavity, and point of inflection. And then at the very end, they go into some slope fields, all right? So let's go over this real quick overview. Well, tangent lines was just y is equal to mx plus p. But you're plugging in the derivative at that given point A you're going to multiply by the value that you're given, right? And you're looking for your b in this sense, or your y equals mx plus b tangent line. What you can understand here is if you have any slope, you're picking a certain point right there, and you're ultimately drawing the smallest triangle of slope that you can, and using that to dictate a tangent line, a line that would dictate what would, potentially continue happening. Let me give you a better example here, actually. One thing to think about is, for example, we might be driving on the highway, and let's just say this is our speed, okay? And speed and distance away from home. So this is the miles away from home, and this is time. So as we go and we're moving away from home, let's say on this trip, Google Maps actually has calculated all this information here. They know how fast you've been going overall. That's the mean value theorem, okay? They know the overall average speed. They know the current speed, okay? So the current speed, I'll use this blue triangle. They can estimate and say, oh, hey, if you continue accelerating and going faster, that's how far you're going to be later, okay? But if you slow down and go a slower rate, then it's going to take this long, and it'll be, it'll take this much extra time maybe to get you to the same spot, okay? So linearization is actually the actual calculations of those. Tangent line is the y equals mx plus b estimate line that you would use. It's just basic algebra, but you're plugging in the calculus terms into your slope. So keep that in mind. Then what you have with linearization is the estimation of it. What would actually happen if you continued at that rate, and you would use your y equals mx plus b, the formula you were given, and you would estimate and add on with the given slope to determine where you would end up. Obviously, if that doesn't quite make sense, let me know. I'm more than happy to help further explain that for you. Then what we have here is implicit differentiation. And I've got this, but I'm actually going to pull up a different page so it looks a little bit better. Yep. And when I see implicit differentiation, what it basically is you'll notice these situations in which you're no longer driving with respect to just X. This is the standard that we're used to, okay? And what we do is with the X situation, that cancels out the dx. When you drive with other variables, you got to remind yourself that dx, dy, or dx, dt, etc., those can pop out as what I like to say, these leftover terms, okay? Because a derivative doesn't derive with respect to that variable, okay? The way that it reads as well, I like to think of this in terms of like a 3D printer situation, is with relation to the movement of X, how do you want Y to move? How do you want R to move with the relation to X moving? I understand that might not quite make sense here, but as we continue going further through the language and the vocab, it'll start to form itself, okay? Now, once you're familiar with these types of implicit differentiations, understand that you got to be careful with any sort of multiplication situations, quotient rules and product or chain rules as well. But then you lead into your related rates, okay? Related rates are one of the most useful, things that are used for our calculus. It is something that is used for like 3D printing and machines that we use, because it helps us calculate where the needle or where the printer, the 3D printer needs to be overall. So the three main steps, every book kind of explains it a little bit differently, but it comes down to this. You have a basic factual function. The common ones you'll have are the Pythagorean theorem, like I've shown you above. But it'll be respect to t, okay? Because now everything's moving with respect to time. But you can get, your volume, your pi r squared of your area for a circle, or surface area, etc. There's a lot of different basic functions that you can think of that you've learned from your previous classes, okay? You're not forming a new function here. Now from that, they'll give you a variable or a replacement, because oftentimes these functions have too many different variables to use, and they'll find a relationship between them for you to eliminate one calculation. And at the end of it, what usually ends up happening is you're solving for a specific rate, one of the three of these, if anything, and for this Pythagorean theorem. And at the end of the day, one of them might be 0 because it's not moving. Be careful. There's sometimes a rate of 0 that happens, but you're often solving for just a single rate that you're looking for, or sometimes the value of one of these, the X or the Y that is there. You'll very commonly see ladder sliding down a wall, baseball diamond run, the plane flying overhead, right? And the angle of elevation that exists between the two. Things like that. Again, try out more problems if you have issues with them. There are ways to get your answers and check them with me, so let me know. Okay. But that's really what I wanted to go over today with you guys, get you guys the understanding of implicit differentiation and the underlying things for Calculus AB that you should have in place so far. Okay. Hope that was useful. Keep studying, you guys, math superstars, and we'll be in touch. Please subscribe and give me a thumbs up if you do find this to be useful. All right. You guys have a great day.